It's a great pleasure meeting you all in another video. In this video, I hope to discuss about what is EMF, the electromotive force. It is often misunderstood as a force. To understand it clearly, let us go from the fundamentals. Now, here I have a resistor, and on the resistor we have potentials VA and VB on either sides. If VA and VB was equal, what do you think about the current? It is 0. But if the potential VA was greater than the potential VB, then a current flow along A to B is observable. Therefore, we are able to understand that a potential difference is a fundamental requirement for the current to flow. What do you think? Can a wire spontaneously create a potential difference? No, right? That's where a EMF source comes into action. To understand better, let us go through an example. I have got a battery of EMF 2 volts. The negative terminal is at 0 volt as it is earthed. Since battery creates a potential difference of 2 volts, positive terminal has to be at a potential that is greater by 2 volts than its negative terminal. Each edge has 0 potential and 2 volt potential. Thus, it has created a potential difference of 2 volt against the resistor. Now you must have somewhat idea about what is an EMF source. It creates the required potential against a load. To understand better, let us go through a few more examples. Now I have got a system where the negative terminal is at negative 2 voltage and I have got a battery of EMF 4 volts. So if I ask you what is the potential at its positive terminal, and if your answer was 4 volts, that's incorrect. Then let us go through again. The purpose of a cell is to produce a potential difference mentioned on it. Here it's mentioned that it would create a potential difference of 4 volts. So from the negative 2, it creates a potential difference of 4 volts. That is, the positive terminal has a potential greater than minus 2 by 4 volts. Therefore, it is 2 volts. To understand much better, let us go through a few more examples. Here I have got two batteries, one with 3 volt EMF and other with a 5 volt of EMF, and the edge is at 2 volt potential. Now we are supposed to find what is the potential at the right hand end. The 3 volt battery ups the EMF by 3, therefore it's 5 volt at the center, and the 5 volt battery ups by another 5, therefore the potential at the right hand corner is 10 volts. Let's try to figure out what is the equivalent of this combination. You need a battery that could up the voltage from 2 volts to 10 volts. Therefore, we must use a 8 volt battery. Now it's clear why we add the EMF of batteries when they are in the same order. Let us figure out the equivalent of this system. You have got a 8 volt battery and a 3 volt battery, and a potential at the left hand end is 1 volt. Now the 8 volt battery would up the potential by 8 volts, therefore the potential at the center is 9 volts. What do you think? Can you have two potentials at a single point? No, right? From some potential on the left, the 3 volt battery would have upped the voltage by 3 volts. Therefore, let's say x plus 3 is 9 volts. Then x should have been 6 volts. Let us try finding the equivalent. You need a battery that could up the potential from 1 volt to 6 volt. Therefore, you should have been using a 5 volt battery. Thus, it's clear when you have batteries connected in opposite direction, the equivalent is found by deducting one from another. Let's look at our last example. Most of the time, students have a common doubt that the negative potential of a battery has to be always 0. But that's not right. It may be any. It may be a positive, negative, or a 0. Now we have minus 5 according to this example and a 3 volt battery. Therefore, the potential on the right hand has to be 5 plus 3, that's minus 2 volts. Therefore, positive potential also can be a negative, positive or a zero value. 1981 question number 21. We are to find the reading of this voltmeter. So this is the setup. Now, if you observe, the potential difference across the 2.7 resistor and the voltmeter are the same. So if we could find the potential drop across 2.7 volt, that has to be the answer. Applying Kirchhoff law for the circuit, we obtain the current flow as 2 ampere, and finding the potential drop across the resistor, we have 5.4 voltage as the answer. That's easy. Let us approach the question in another aspect. Let's try if we obtain the same answer if we consider the potential difference across the battery with the internal resistance. For ease of simplification, I'll earth the right end. Now we have a 2 ampere current flow through the 0.3 ohm resistor. Thus, by calculation, we find there should be a potential difference of 0.6 voltage. From 0 drop of 0.6 voltage, the potential at that point is minus 0.6 volt. Now we have got a battery that could up the potential by 6 volts. That's 5.4. Therefore, the reading of the voltmeter is 5.4 minus 0. That's again 5.4, and that's the answer. Next we have question number 45 from 1993. You all might think, when we have a simple method, why should we think of those tough methods? I recommend exploring because almost after 12 years you get a similar question, but without that idea, answering might be tough. Let's try in our general method. Let us mark the current first. If you observe closely, you have a total of 4 unknown terms. 1. The potential difference, the simple current I, capital R1 and R2. Thus, you will need 4 equations to simplify the answer. This is an MCQ, so you won't be able to spare that amount of time. Let us see what is the other method. The potential difference across the voltmeter is the potential difference across the battery with the internal resistance. So let's consider that portion separately. For ease of simplification, I'll earth the negative end. By calculation, we are able to find the potential drop as 0.4 volt. Thus, the potential at that point marked in green has to be minus 0.4 volt. We have got a battery of 6 volt EMF. Per discussion, potential on the positive side is 0.6 voltage.